Let's start with geo-replication. But basically, it was one of the first primary use cases or one of the key features in Pulsar, why Pulsar came to be when it was first implemented in Yahoo in 2012. And the use case for Yahoo was to replicate the real-time data from Yahoo Finance, all these different stock ticker quotes across 8 or 9 different geographical regions, right? So it needed to be a full mesh geo-replication. The data would come in from a single source, let's say the New York Stock Exchange floor, and we wanted to get that data over to the servers in the APAC region and the Europe region and all these different regions as quickly as possible. And that needed a good geo-replication story. So that was what was built, was that geo-replication, again, is set up on a per tenant basis. So each tenant is considered its own logical group or department, and it can control what data it wants replicated where. We delegate that role from the super users down to the tenants, and the tenants are what control that geo-replication. So in order to have geo-replication between clusters, the tenant has to exist on all these different clusters. As we saw with one of those permissions, we set the geo-replication rate, we set the allowed, what clusters they're allowed on. That's where this comes into play. You can only enable geo-replication when the tenant's on both clusters or whatever clusters you're replicating between. And it is managed at the namespace level. So it's enabled at the tenant level, but it's managed at the namespace level. The model it uses is local store and forwarding sort of a message. So it gets written to the local cluster first. When messages are produced to Pulsar topic, it goes through the traditional path. It comes into the assigned broker that has that topic, puts it in its local cache, writes, n number of writes to the bookies, gets the ACK quorum back, acknowledges it, and then it's done. Now, once you have geo-replication involved, then at that point, only after it's been acknowledged and the data has been stored locally, in the background is the message eligible to be asynchronously forwarded to all the different target clusters in which it's to be replicated to, right? So the message is typically they're replicated immediately. There's very little lag. They're almost, at the same time they're dispatched to local consumers. So really your latency in general in practice is bounded by the physics of the network round trip time between the remote regions is your latency. So it's geo-replicated as fast as physically possible in most cases, with the exception of that rate limiting that might come into play. You can impose some artificial latency by setting up these, we talked about in the previous section, those rate limiting on the geo-replication, but in general, it is bound by the physical capabilities of the network itself. So if you want to enable it, it is a 4-step process, right? So the first is to create a Pulsar instance, and we'll walk through that. Pulsar instance is this logical grouping of multiple clusters, and you have to have a separate metadata store for that so that the tenants can be created there, and you can set up the policies there. That is really what a Pulsar instance is. Then you create as many replication clusters and assign them underneath that Pulsar instance as you need. So in this case, let's just say you're going to have 2, you create cluster A, cluster B. They have to join that Pulsar instance that you created. You have to have replication set up between those 2 tenants. The tenant has to exist in all of these clusters in order for it to work. Third, you grant permissions, tenant permission across the replication clusters, right? So now you set up the tenants exist in these different clusters. You enable them so they have permission, again, with that allowed clusters permissions. We look at the capabilities that we saw when we were setting permissions in the authorization section. You have to grant them this tenant permission across all the clusters that you intend to replicate to. And then finally, you configure the geo-replication policies at the namespace level, and that's it. Geo-replication takes place from that point forward. So let's walk through this step by step. First is creating a Pulsar instance, right? Again, this is a holding a container for multiple Pulsar clusters so they can work in unison. These clusters are intended to be distributed across different geographical regions, and you can by being part of the same instance, you can geo-replicate the data, across these regions. Now, to deploy a multi-cluster Pulsar instance, you have to do the following 2 steps. There has to be 2 separate metadata quorums or ZooKeeper quorums. One is a local quorum for each cluster, as we've been talking about. So we've always shown that chart. You have these number of bookies, you have these numbers of brokers, and you have this metadata store. And that metadata store, configuration store, holds all those policy data, the managed ledger information for the data inside that local cluster. Then there is a second metadata store that contains information about the clusters inside the instance themselves, and the policies and geo-replication policies are defined in this metadata store with that. So there's two different, and we have a graph that shows this better, but there's two different places that you keep data, and this metadata is an additional net new one outside of the original Pulsar cluster. Yep, so here's the instance here. Looking at this graphically, you have a single Pulsar instance, and you can have multiple Pulsar clusters assigned with that. Each one's going to have its own local configuration store associated with it as it did before. There is no difference across that. But then there's a separate configuration store for the Pulsar instance that's called a global zookeeper, in this case, a global zookeeper cluster. That keeps track of metadata about all these different clusters that belong to the instance. So that's information that's retained here. It also retains policies about the geo-replication. I'm replicated from cluster A to cluster B, or this particular tenant has access, and so on and so forth. So this keeps a separate set of metadata that overarches all of these clusters. Now, since this is a global zookeeper cluster, you want to geographically disperse these zookeeper nodes across different regions, ideally, right? So again, if this is region A and region B and region C, ideally you could put a zookeeper node in each one of those as part of the zookeeper cluster to make sure you have high availability as well, that everybody has access to it. You should have this availability as well. So this is typically how you stretch that zookeeper cluster stretched out. So once you have created your metadata cluster and set it up, once you set up your cluster specific zookeeper, configure the store forms, you need to initialize that metadata here. So again, the first time you set up, this is for your local Pulsar cluster, you initialize the cluster metadata once, and you specify all your different information, what the cluster name is, where its metadata store is. In this case, we're using Zookeeper, two different zookeepers here, and you're specifying where the configuration metadata store is as well. So this is the part that says, hey, this is the global zookeeper information. This is where my web service is. This is my TLS encrypted web service. This is my broker endpoint, et cetera, et cetera. You initialize all this cluster metadata. This is information that has to be stored in that global zookeeper instance so that we know if we want to replicate to the US West cluster at some point, we know how to connect to it, right? This is the metadata that tells us, okay, this is how you connect to this endpoint. This is this guy's cluster. This is the metadata store that we're connecting to. So this is a key component, and you do this for every single cluster in the instance itself, right? So you have to identify that information. Next, you need to add the cluster to the global configuration store by doing this as well. So once you've initialized that metadata, next thing you do is you create that particular, again, this is on the global cluster store. So I first configured the global geo-replication store. Now you can go locally and say clusters create. You give it, again, the full path name of where the US East cluster is going to be, DNS name, it's port 8080, it's port 6650. This is the data port. This is the administrative port, and associate that metadata with the tag US East for that cluster. This identifies that cluster as being part of that particular form, and now it exists, and this is the specific metadata for it. If instead, and that was the non-secured one. So again, this is the plain text, non-secured information. If you need to, and you probably want to use it as secured cluster, obviously you're doing geo-replication, these are going to be production clusters. They're most likely secured. So you use a different switch for that. You specify the secured broker endpoint. Again, this would be like the 6651. This would probably be Pulsar or plus SSL. Similar for the endpoint, this is probably going to be, HTTPS, not HTTP, and it's going to be port 888443 rather than the port 8080 that's typically used. Also, you want to specify the authentication mechanism you're going to use, whatever class. In this case, we're using mutual authentication TLS, and providing the specific parameters like we did for the clients, right? So I'm authenticating to this broker, I'm connecting, I'm doing, I'm creating a producer on this topic basically for geo-replication purposes. So I need to authenticate. These are the credentials I need to do it. And then again, you specify your cluster name. So again, there's different ways based on how you're authenticating. This is probably the most likely one. Now, next, when you create a tenant to replicate to a cluster, the tenant needs to have permission to use that cluster, right? So when you grant permission to the tenant, you also granted the allowed clusters, which is kind of what we were talking about in the administration thing. But we always took the default of local cluster only, right? So you can, when I say create a tenant, this is a command. I can specify the admin roles. I also specify those clusters that this tenant is allowed to operate on. So again, these clusters had to first been created with the previous steps. So as we saw, US East and US West were created in the previous slides. Here, US West, US East. Now that they exist, I say allowed clusters. This tenant is now can operate on all these different clusters. It goes in this order. Then last but not least, initially, the namespaces are not assigned to any cluster. So you create a name, you create a geo-replication namespace and to the clusters to use using the set clusters command. So here you say, okay, now I'm creating a namespace and I'm setting this namespace to run on this namespace, my tenant, my namespace to run on these clusters. Where is it going to be geo-replicated to, right? It does not have to be a full list. This is how you can control these different active passive policies. You're saying this namespace exists on a subset of these, exists on all of them. That's a full mesh. If I wanted to do just bi-directional, we have 2 clusters, so on and so forth. You're specifying which clusters this namespace can operate on. Now, once you've created this geo-replicated namespace, any topics that producer or consumers created with that namespace are replicated across those clusters automatically. So the next step is if you've created a topic on this my tenant, my namespace, and start producing, automatically with this policy in place, it will geo-replicate that data, all the produced data that's published on US West will get replicated to US East and US Central in that regard. So that happens automatically. You can further control it if the namespace level, again, so that's globally for all the topics in this namespace. If you further want to limit or expand where a topic level replication occurs, you can do that as well. It's the same syntax using just the topics command rather than the namespaces. And you can either make a bigger list or a smaller list, and you specify the entire topic name. So again, now any production on this particular topic with this replication gets replicated automatically across all of these clusters, whichever clusters you specify with that. So that's really all that has to be done.